Hello, welcome to the ASME Dynamic Systems and Control Division podcast series. Before we get started, I want to remind everyone to please subscribe to our YouTube channel so that you can get the latest updates on new episodes.
Greeting audience, welcome to ASME Dynamic System and Control Division podcast series. I'm host Hao Su from City University of New York. In our podcast series, we have conversations with the researchers and members of our community to share their experience and perspectives. Today, we are very fortunate to have Professor Chris Vermillion, who is an associate professor at NC State, joining us. His research lies in control and design optimization for renewable energy and energy efficiency. He's working on some very cool work, like underwater energy harvesting kites. Hello, Chris. Welcome.
Well, thank you, Hao, and thank you for the invitation to be here. It's certainly great that you're organizing this podcast series, and it's really an honor to be part of this series, especially considering the very, very strong caliber of the first four people who provided podcasts. So I hope I can rise to that caliber, and people will enjoy this podcast just as much as those.
Thank you. We are very honored to have you here. Chris, could you please give us some overview about your research?
Well, absolutely. So as you alluded to in the introduction, your very kind introduction, my lab is the Control and Optimization for Renewables and Energy Efficiency Lab, or the Core Lab for short. And so what we do is we take advanced optimization techniques, and in particular, advanced control techniques, and we apply them to renewable energy systems and also energy efficiency in general. And so our one sentence slogan in the lab is we're revolutionizing energy harvesting and energy efficiency in the air, on the ground, and underwater. And hopefully we'll get a chance to talk about some of the projects that we're working on in that area. So in terms of our portfolio of applications in the lab, there's really three application areas that we're focused on right now. Perhaps the one that I'm best known for and the lab is best known for is tethered energy harvesting systems for airborne or wind energy harvesting, and also marine hydrokinetic energy harvesting. The idea there being to replace the conventional tower with tethers and what's called a lifting body in order to be able to reach winds at high altitudes and also harvest marine resources in very deep waters that would be inaccessible to towers. But also by doing that, we're able to use carefully designed control techniques to actually impart motion into that tethered system, something that you couldn't do with the towered system, in order to harvest an order of magnitude, as much as an order of magnitude more power per unit mass than you would be able to get with a conventional system. So that's one of those three categories in the portfolio. Another category is connected and autonomous vehicles. And I've been involved in the Next Car program by ARPA-E, so people might be familiar with that. It's focused on using connectivity and autonomy to achieve very significant fuel economy improvements. Our team's focus was on heavy-duty diesel trucks. My third application area within that portfolio is probably the newest, and that's one that we call in the lab renewably powered robotic systems. In particular, we're interested in mission planning and control aspects. These are robotic mobile systems that are powered solely by a renewable energy source. So wind, solar, or waves. Some examples being sailing drones, wave gliders, solar-powered autonomous surface vessels that can do oceanographic observations. And the challenge here is, whereas most mobile robotic systems can be characterized by relatively predictable mobility, but very, very limited range, now you have stochastic mobility, but unlimited range, and that demands a new paradigm for mission planning and control. So that's just an overview of our lab, and excited to dig into some of that more.
Wow, I think that's really a broader spectrum research. I think that's really, really interesting. And also it sounds like, I think it can solve a lot of like real world problems. Yeah. I think following your work over the past few years, I think you have not only worked on a lot of highly customized energy harvesting systems, but then this system have become larger and larger in scale. Have you experienced some challenges as you moved to this larger scale environments, particularly with the restrictions associated with those the pandemic? how did you respond when tasks didn't go as expected?
Yeah, absolutely. This is very important and very relevant to some of the work that we're doing right now in terms of migrating our work in that first area that I talked about, tethered energy harvesting systems to larger and larger platforms. As a matter of fact, we're involved right now in a project that's sponsored both by DOE and DARPA, different aspects of the research sponsored by different agencies, that's focused on the development of a marine energy harvesting kite. So the idea there is you take a high lift wing, fly that wing perpendicular to the prevailing flow. It's tethered to either the seabed or to a floating platform, or to, in the case of one project, an autonomous underwater vehicle that gets recharged when it's parked at the seabed and the kite's deployed. And what the kite does is it flies very high speed orbits perpendicular to the prevailing flow. And it can achieve those very high speed orbits because of its high lift, but that demands very careful control. Now, we've been studying kite-based energy harvesting systems for some time in the lab. And if you go back to my work as an early stage assistant professor back at UNC Charlotte, starting in 2014, our chief experimental mechanism at that time was a water channel based mechanism where we would 3D print and tether and fly basically 1/100th scale models of kite systems in a water channel environment. We have since, with these new projects, moved to a pool-based tow testing framework where we can actually instrument and control kites at 1/10 of a scale. So larger scale, more control capabilities, more relevant to the full scale system. And in fact, with some of our ongoing work, we're going to be scaling up all the way to full scale with some pending proposed work. And with this scale up comes a lot of challenges. As you mentioned, sometimes tests just don't go according to plan. And and that becomes, number one, more likely as the designs get more and more complex, and that's what's happening. We're testing more and more features. Additionally, as we test in larger and larger scale venues, the venues themselves get less accessible. And by that, I mean, when we were testing in the water channel, we could be in the water. It was a shared facility, but we could be there for weeks at a time, all day, every day for maybe a week running our tests. Right now, we're working out of the NC State pool doing some of our tow tests, and facilities has been very gracious to us at NC State. But nevertheless, this is a shared facility, a heavily used facility, and so we only get a few hours a week. So we're testing a more complex system in a less accessible environment. So how do we manage that? And how do we manage that with the new wrinkle of COVID, which has been a challenge? I'm someone who loves a good plan, and I like for the plan to be executed as planned. But understanding that doesn't always work, we do a couple of things as a lab. One of the things that we do is we always have contingency plans. As a matter of fact, we were testing in the pool today, and we reverted to a contingency plan because of some odd and not fully diagnosed behavior that we were seeing in one of our control surfaces. We'll take it back to the lab and we'll figure out what's going on today. But we were able to move to other tests that did not rely on that because we had a well-defined contingency plan. The other thing is in terms of our test plans, we make pretty liberal use of optimal design of experiments and adaptive design of experiments techniques when we plan our tests. So we use formal methods from optimal design in order to adapt our experiments as we go. If one experiment in our test matrix doesn't make sense anymore because of the results of another experiment, we're not going to run it. And so that helps us to make efficient use of that limited facility. Now, you mentioned COVID, which threw just another wrinkle into this. I think COVID was hard on everyone. Certainly harder on some people than it was for myself as an academic. But it was tricky engaging in experimental work during the pandemic. Nevertheless, we did a couple of things that I think really helped out a lot. Number one, knowing that our access to the lab was going to be limited for a few months, we focused very heavily on building up very robust simulation models so that we had clear hypotheses going into testing. The other thing we did is, in terms of our designs, which we didn't have full capacity to fabricate, we brought in a number of experts from outside to do design reviews. And that's something where, as we get into larger and larger projects, I think it's important as scientists and as principal investigators to have a little humility and recognize where we're strong and where we're weak and where we need to bring in experts. So while these kite design and control projects focus a lot on control, they're not entirely control. And so there are other areas of expertise that we had to bring in. And we brought those in, especially because of COVID, especially because we didn't have the opportunity to get things wrong fabrication-wise, because we just didn't have that much time.
Right.
So, and then, you know, in terms of things going wrong, the other element that I think has to be taken under consideration is the personnel that are working on these things. It's very easy for a team to get demoralized when things don't go right. So as an advisor, you know, you have to approach things from a very, very scientific standpoint, not the standpoint, an emotional standpoint of frustration, which can be challenging for all of us.
Right.
But additionally, you know, I think one thing that's helped with the projects that I've managed is I've tried to be present whenever possible at testing events. And we've done a lot of things like appreciation lunches and appreciation happy hours to keep the team morale up. And I think that's really, really important when you're working on a complex project with lots of moving parts and lots of failure points, and things are not always going to work out. You got to keep the team morale up, and you got to approach those failures in a very scientific way, I think. And we try to do that. We're not perfect, but I think that we're in general doing a good job with it.
Yeah, I think it's really interesting to know that you have really a lot of methods from theory to implementation to ensure some resilient solutions, right? To ensure the success of the projects, and in particular during this little bit kind of difficult moment. Yeah. Another related question is, I think your background is very interesting in the sense that you were at a startup company prior to joining academia. So as opposed to doing a traditional postdoc, could you please give us some perspectives on how that experience helped to shape your perspectives as a faculty member, and how your experience in this startup company helped to shape your NSF Career Award? I think the topic is efficient experimental optimization for high performance airborne wind energy systems.
Yeah, absolutely. So my experience working at a startup company prior to going into academia is probably somewhat different from the norm, if there is a norm for people going into academia. But I would say that my experience at a startup, in particular at Alteros, which is a unique startup, was probably one of the best preparations that I think one could have for academic life, for a couple of reasons. Now, one of the downsides was there was less paper writing involved. So I was publishing less than my peers, although I was still publishing, I was still attending conferences, I was still maintaining those connections. But what I was doing more of than I think a lot of my peers was gaining grant writing experience. Alteros was an early stage, very early stage startup at the time, and we were entirely funded on seed money, either friends and family money or federal grants, SBIR
type. Okay.
Yeah, for the most part. And I played a significant role in writing a lot of those grants, and I learned what worked and what didn't work. And I think that was really, really helpful great preparation prior to joining academia. Another great experience I had was the experience of managing a team that went all the way through the process of design, implementation, and unit testing, and actual full-scale experiments.
Right.
So in terms of, you asked about how that preparation helped to shape my research lab and my career proposal in particular. Well, it did a couple of things. So my experience at Alteros helped me to identify some really fundamental problems in the larger field of airborne wind energy. Alteros at the time was focused on developing a lighter than air system for airborne wind energy, so harvesting wind energy through a tethered system. They've pivoted since then, and I should say we've pivoted since then, since I'm still a technical advisor to the company. The company's pivoted since then to tethered systems for telecommunications, but still focused on tethered systems. But at the time, the focus was airborne wind energy systems. And in my experience with Alteros, I was really able to identify a number of fundamental problems in airborne wind and the control aspects of airborne wind, because I was a control engineer there. My background, my PhD was in control. And that really allowed me to establish an independent identity as a researcher going into an academic position, which I think is so important for something like the Career Award. So this was an identity that was still in the area of control, which was the focus of my PhD, but highly differentiated from my PhD work and my PhD advisor. It was really a unique identity. The one thing that was uniquely led by me when I was at Alteros was the development of a water channel-based experimental platform for characterizing these tethered energy systems at very small scale. I mentioned before, we used to 3D print, tether, and fly these models in a water channel. We started out with very simple passive setup. Once I joined academia, we moved to an actively controlled setup, and since then, of course, as I mentioned, we're moving toward larger and larger scale toe testing of these systems. But what that allowed me to do is again establish a test bed that was uniquely mine and uniquely something that I could run with and further develop as part of my early career work as a faculty member. So I think it was a great experience in that regard.
Yeah. I actually also worked in industry and Philips Research in North America for 2 years. And I designed some surgical robots for the lung intervention and also cardiac intervention. Yeah, I think I share some similar experience. I think really give you kind of different perspective, different experience outside of academia, right? And I really help to prepare the next phase of the academic career. Yeah, I think that's really, really useful. Yeah.
I absolutely agree. Yeah, there's certainly great value in academia, but certainly during a PhD program, you get so focused in one particular area that I think is very helpful to the startup. Is in a sense the complete opposite of that, where you have to wear a lot of hats as a member of an early stage startup. But even working at Philips, I think it's a different environment than the academic environment. And I think it really helps to build perspective.
Also, I think you mentioned about your NSF Career Award. Could you please share some tips how to prepare a successful NSF career proposal?
Absolutely. So I would say that the biggest issue that I see in career proposals that I'm asked to read or that I review is applicants who simply just propose the next little tiny increment relative to their PhD work. And it brings me no joy when I get those proposals and I have to tell them, hey, when they're asking me for my informal feedback, and I have to tell them, hey, this doesn't look any different than your PhD thesis. And I think that a lot of early career faculty don't even realize that this looks just like their thesis, like it's because
that's true, yeah.
When you're so ingrained in a narrow topic, even a contribution that looks incremental to everyone else in the world seems monumental to you. And maybe it is monumental, but it's really on the PI to make that case. And I think that case is often not made. And the consequence of that is, and I'm not advising people to go out and pursue a field that's completely different than their PhD, but I'm advising the people to make sure that they establish a unique identity in the field, because the reality is, and you know this as well, the Career Award it's not just a research award. You certainly have to have good research content, but it's a career development award. And so you've got to say how that award is going to turn you into a leader in a particular area. And for that, it really helps to come in with either an identity in a field or a desired identity in the field. And for me, the Career Award helped me to do two things: establish myself, number one, as a leader in the application area of airborne wind energy systems, but also we viewed the water channel based lab scale characterization platform for tethered systems as an experimental co-design platform, a platform where we could simultaneously optimize the plant physical system and the control system. And that recognition, in addition to the recognition that the co-design community, although it had done some great stuff over the years, was really lacking in formal experimental techniques. That recognition and the fusing that recognition with that platform really helped to establish me in the co-design field as well. And so I think that's the important thing is the career award. It's about you as the applicant, that is, and the applicant establishing a unique identity in their chosen field.
Right.
And if that point or if that case can be powerfully made in the career proposal, then I think that the career proposal will stand a much better chance. Of course, I offer the advice that you probably hear from everyone else as well, which is with the career proposal, you have it's your award, but senior faculty are generally going to be pretty willing to provide their advice, and I always advise people to get as many people's feedback as possible. Some people worry a little bit about their ideas getting stolen if they share their ideas with other people. I'll tell you, there are some bad actors in the world of academia. I'd like to believe that there aren't any, but I think that it's generally worth that risk to share your proposal with someone. I have not had a proposal idea just scooped from me yet.
Sure.
Because I've talked about my idea, and I think it's really useful to get feedback from as many people as possible. I think the other thing that's really useful is not just to give them your written draft, but also talk face to face. There's something about making an elevator pitch of an idea where not only do you get feedback from the person, get to watch their facial expressions as you're describing their idea, which may or may not be good, but there's a feeling that you get, at least this happens with me, there's a feeling that I get when I'm describing a new idea of mine to a colleague. And sometimes that feeling is, boy, this is really a good idea. And sometimes just verbalizing it, I think to myself as I'm verbalizing it, man, this idea kind of sucks, or man, this has a lot of holes in it.
I have the similar feeling. I totally agree with you.
So if anything, exchange your idea verbally, just because you'll get a better picture, a better feeling of
I think for your second tip, I think initially when I try to talk with the program director and NSF, I feel like, okay, my idea is just an okay idea. I feel a little bit shy to share with them because I think, okay, that really is kind of feedback, right? So how to better prepare and have better ideas and or at least a better presentation, right? To show, to write this proposal, And also for your first tip, I think the career award certainly encourage applicants to explore new frontiers, right? And in particular, how to find some unique identity, right? I think that's very important. How to think out of the box to differentiate from advisors, postdoc advisors, right? I think those are really crucial, but sometimes it's not very easy to see at the insider, right? So I think it really need to think differently. I think maybe the last question is, what is next on the horizon for your research?
Well, of course, we don't always know what's on the horizon because we don't know exactly what the results of the scientific experiments are going to be. You know, the quote, the joke that I sometimes make with the students in the lab is, "Oh no, my scientific experiment did not go the way I planned." Nevertheless, we do have a few things cooking, and I'm happy to share those with you. So one is the scale-up work with the energy harvesting kites. So if things continue to go well, then you'll see us moving from pool-based tow testing of a 1/10 scale kite system over a 25-yard tow length, which is pretty short tow length, to open water testing in the fall and again in spring of 22. So in fact, we're now permitted to do open water testing in Lake Norman in North Carolina of our designs in the fall and spring. So we're looking forward to that. We're looking forward to posting videos. By the way, as a shameless plug, go on over to the Core Lab website and check out the existing videos of our pool-based testing. But we'll be posting more results. The lake's kind of murky, so it's unclear how good the videos are going to be. No pun intended by the unclear comment. But, well, we'll post the data. And we're going to be scaling this up in collaboration with a defense contractor that we're working with, if things go well, to a full-scale system that actually provides power to an autonomous underwater vehicle when that vehicle's parked on the seabed, which gives it very, very long endurance because the vehicle can do its mission, park, deploy the kite, retrieve the kite, and then continue on with its mission. So that's one definite area of forthcoming research. The other big area, I think that we've now got one grant for, and we're working on some other avenues, is this area of renewably powered robotic systems that I mentioned. Particularly, like I was mentioning before, the mission planning of mobile systems whose primary or sole propulsion source is a renewable resource, which gives them infinite range or very, very high range that's not dictated by the resource, but by something else, but stochastic mobility. And so we're working on mission planning strategies that leverage notions and retailer notions of things like dynamic coverage to tailor them to that stochastic mobility. We're actually building a very small fleet of sailing drones, small scale sailing drones, about 1 meter in length, to test some of these algorithms in the lab. And we're talking with some companies as well about doing larger scale projects with sailing drones and or solar powered vehicles, where the goal is to use a renewably powered robotic system to do oceanographic observation. So that's something to keep an eye on. Like I said, it's the newest focus area of the lab, but I think it'll become a big focus area as the lab moves forward.
Yeah, I think those sounds really exciting. I really maybe one day to see those prototypes you are developing. I think that will really tackle some grand challenges for energy systems. And finally, really appreciate you to share your experience and perspective. I think that's really inspiring. And thank you so much.
Well, thank you again for the invitation to be part of this podcast series. I hope everyone enjoyed it. And again, it's a real honor to be part of this. And I think it's really great that you're setting up this series.
Thank you.